Affine Transformation. In this video, we're going to learn affine transformations and the difference between linear and affine transformations. The outcomes are knowing the affine transformation of a vector and rigid body transformations. So far, we have learned about linear transformations. We also learned that translation is not a linear transformation. We now look into another important class of transformations called affine transformations. In simple words, an affine transformation is a combination of linear transformation and translation. Suppose A is a linear transformation and T is a vector. The affine transformation of vector x is by first applying our linear map to x, which is a matrix vector multiplication, and then applying the translation. This will give us a new vector y, which is a transformed version of x. A particular affine transformation that combines rotation and translation is called rigid body transformation. A rigid body transformation preserves the distance between any pair of points in the object. Let's look into an example. Here we have a pyramid. We're modeling the pyramid using 5 points and connecting them using lines. Here is the Julia code I used to visualize the pyramid. You can see I'm defining x, y, and z coordinates of 5 points and stacking them into a 3 by 5 matrix E. And then I use the following lines to visualize the previous figure. Now we want to rotate the pyramid and then translate it, which will be a rigid body transformation. Here you see that we're using the rotation about the x-axis and the translation vector t. We use the rotation angle alpha, and the translation is 0.5 is along the x-axis, 0.75 along the y-axis, and 1 along the z-axis. And here you see, after applying the transformation to each point, they are transformed into a new location. So the red pyramid is the transformed pyramid. Now let's see how we can do this in Julia. First, I'm defining my 3D rotation and translation vector. Then I'm using Julia's tools to apply the rigid body transformation to all 5 points in one line. You probably want to look into this line and understand what's going on. And then I use the remaining lines to plot 2 pyramids. You are now ready to tackle project 1, which you will use LIDAR point clouds and given transformations to build a point cloud map. This map is typically used in robotics, and you will use a real data set to create a map.